Boom. Alright, so today we're going to do the chapter 8 review. We're on page 328 in your books. Okay, number 1 will not be on there, but we can start with number 2. Okay, so number 2 says solve, and it's kind of what we've been doing. 5 cosine of theta equals -1 for 0 degrees is less than or equal to theta, which is less than 360. Okay, and that's actually kind of what we just got done doing yesterday. So what's our goal when we solve a problem like this? We got to get theta by itself. Okay, so if I get theta by itself on this problem, all this stuff, what does this thing tell me? What mode would I have to be in if I have to use my calculator? Degree mode, okay? So that's all that tells me, is that it's going to be in degrees. Okay, so let's get theta by itself. What's farthest away? 5. How do you get rid of that 5? You divide by 5, what you do to one side, you do to the other. So now I have cosine of theta equals -1/5. Okay, I would first go to my unit circle. Okay, on the test, I think all those are on your unit circle. But I'd look at my unit circle. Is there a spot where -1/5 is a cosine value on the unit circle? And there's not. So since there's not on my unit circle, what do I have to do now? Go to my calculator and plug it in. Okay? What's the opposite of cosine? So how do you get rid of a cosine? We do the cosine inverse. But what you do to one side, you have to do to the other. Okay? So these cancel. And I would be left with theta equaling, and then I would just plug it in. So turn my calculator on. I would go second cosine of -1 divided by 5. And before I hit the answer, what mode do I have to be in here? Degree. Degree. So go to degree mode on your calculator, and then hit enter. And how many degrees is this answer? 101.5 degrees. We'll just leave it to the nearest tenth. I think the direction said nearest tenth in your book. Okay, now normally there's 2 answers on these. I'm not making you calculate the second answer if you have to use your calculator in the test. Okay, let's solve number 3 next. Okay, so number 3, another solving problem. I'll just write the solving out, but it is another solving problem. Except on this one it says 0 is less than or equal to theta, which is less than 2 pi. What does this part tell me here? Radians. So that's all that tells me is it's in radians. I do the same solving. So what do I do first to solve this problem? What's my first step?
Subtract the 3 over.
3 is the farthest away, yep, so subtract the 3. What you do to one side, you do to the other. If you don't use something in algebra, we bring it down. Okay, what's the next thing that's farthest away from the variable on the same side? Negative. How do you move that negative? You multiply by a negative, or you just switch the signs? Okay, so now I've switched the signs. Now I got cosecant. Is that one of my 3 functions, my trig functions on my unit circle? No. What is related to cosecant though?
Sine.
Sine. So if I did the reciprocal on one side, what do I gotta do to the other? Reciprocal. What's reciprocal of this? -1/4. Now is -1/4 on my unit circle?
No.
And I don't think it is it?
No.
Okay, so then what do I do from this step now? Calculator. Now how do you get rid of sine? We do the sine what? Inverse, and what you do to one side, you do the sine inverse to the other. which means those cancel and I'm left with x equals, now what mode do I gotta be in my calculator now? Radian, because it's 0 is less than or equal to theta, which is less than 2 pi. So I gotta be to radian mode. Go hit enter there. Then it's second sine inverse of a negative 1 divided by 4. And what is the value? Negative 0.25. So that would be my answer there. Again, I'm not making you calculate the other stuff, so whatever the calculator gives you will be the answer. Alright, let's jump to number 5, yep. Okay, so let's do some graphing. So let's graph this. So it says graph is the directions, and they give me y equals 3 sine of x over 2. Okay, and then it says give the period and amplitude. So give the period and amplitude. Okay, so let's do the amplitude first because that's the easiest here. What would the amplitude on this function be? 3. Okay, next part is the period. There's a formula on the back of my unit circle. What's the formula on the back of my unit circle? Period equals 2 pi over b. Now what's my b here? Technically this is a what? A fraction in front of my x of what? A half? So what's my b on this problem? Half. And what happens when you divide by a fraction?
Multiply by its reciprocal.
So the reciprocal is now what? 2 over 1. That goes away. What's the period now? 4 pi. Okay, let's graph it. So the amplitude means it's going to go up 3. And you guys have to label these on the test. If you don't label them, you're going to get points off. So the amplitude must be labeled. Where does sine always start at? The y-axis at the origin, right? Okay, so the sine would start here, and since this is positive 3, which direction does it go first? Up, and then down, and then back. How many quadrants do I need to split that into?
4. 2.
Need to split it into 4 quadrants, correct. Okay, so this would be 1 mark here. And if you want to label it quadrant 1, if that helps you to figure out where the quadrants are. The x-axis tick marks is what I need labeled though. So what's the final part right here? I know that right now. What is that? 4 pi, right? So if I take my period, my full cycle, and I split that into 4 equal parts, what would I do with this 4 pi then? Divided by 4, so what's each tick mark worth? A pi, right? So that's 1 pi, this would be what?
2 pi.
2 pi, this would be what?
3 pi.
3 pi, 4 pi. And again, if you want to split that into 4 quadrants, quadrant 1, quadrant 2, 3, and 4, there's my 4 quadrants. And then that would be graphed. Questions on that? Alright, let's look at number 6 in your book. Okay, so 6 now. So number 6 in your book. I'll draw a picture out there. You guys can try to figure it out. Okay. Let's figure out the equation for that, and I want 2 equations, a sine and a cosine curve. So on the test I'll ask you for both. Okay? If I want to find an equation, so I'm going to do two equations here. Y equals, I'm going to do a sine curve and a cosine curve. Okay, so I need to fill in my A, my B, my shifting left and right, and my shifting up and down. Okay, what's the first thing I need to find here in this picture? The middle part, right? The axis of wave. Where would the middle of this be located?
1.
1. So if you counted it out, you could be, here's the peak, here's the valley. If I go 1 here, and then I get 1 closer, you can see the middle line would be at 1. Okay, and where is that? So again, this is called the axis of wave. Where's the axis of wave located? That's the vertical shift, right? That's my new x-axis. So what happened to this graph? It shifted up how many units? It went up 1 unit. How can I find the amplitude? Because I need to figure out the A, which is amplitude. How do I do that in my picture here? From this axis of wave, can I figure out how high and how low this guy goes? How high and how low does it go? Should be the same because that should be in the middle, right? It goes up how many?
2.
2, and it goes down?
2.
2. So my amplitude is?
2.
2. So then I can fill in a 2 for my amplitude. It goes up 2 and it goes down 2. Okay? What's the next thing I need to fill in? Probably the letter what that normally sits here? B? On the back of my unit circle, I should have a formula. B equals 2 pi over period. So we need to find the period in order to figure out what B is. How do you find the period? That's where the cycle completes, right? So what do I normally go from? Peak to peak or valley to valley? Does it land nicely on the peaks? Maybe I didn't draw it correctly from the book. I don't think I drew it nicely from the book. The second red part of the curve should be shifted a little farther over. Alright, so if I went from peak to peak, from here to here, how far apart are these guys?
4 units.
4 units, right? From 1 to 5. Okay, so if they're 4 units away, my period is 4. And then how do I figure out B now if I have 2 pi over 4? What's 2 over 4 simplify into? Pi over
2.
2. So now I have pi over 2 and pi over 2. Okay, what do I still need to find out? The left and right shift. Okay, if I have a sine curve, where does my sine curve normally start at? The origin. So now my new axis of wave right here, would this right here be my sine curve starting point right here? Yeah, did that shift anywhere? So then since there's no shift, I can put a plus what?
0.
0. Where's cosine normally start at? Oh, here's one other thing. Did this sine curve go upward first? Yep, since it goes up, it needs to be positive in front, and is it positive in front? Yes. If it went downward first, then you'd have to put a negative out in front. Okay, where's cosine normally start at? Peak. So here's where the peak would be. How far over did I have to shift to get to that peak?
1.
1. But we always do the what? Opposite. So instead of a plus 1, it would actually have to be a what here? A minus 1. So that'd be it. Because on the inside we always do the opposite. Questions on that? Alright, so that's shifting. Let's jump to 8A. Okay, so 8A we got cotangent of A, secant of A, minus cosine of A. Okay, we're going to simplify. So there'll be a couple problems for simplifying on this test. Looking at the test, there are 10 questions. So one question, I'll come back to that at the end, I guess. We'll do this right now. These simplifying problems, there are 3 of these simplifying problems. And then there's 3 of the last section that we did. Okay, what's my goal here when I'm solving a problem like this? What's something I should maybe think about doing? Converting everything into sine and cosine? What's cotangent the same as? Cosine of A over sine of A. What's secant the same as? 1 over cosine. What's cosine the same as?
Cosine over 1.
Cosine over 1. Now you could do 2 things. You could find a common denominator in here, or could I just distribute in? So let's distribute this guy in here. When I distribute and multiply these 2 guys, what happens with these cosine A's? They would cancel out, right? And now what am I left with here? 1 over sine A. Okay? I'll get rid of that crossing out stuff there. Okay, let's say now I distribute to this one. What would I end up with now?
Cosine squared
Cosine squared A
over sine.
over sine A. Okay, are these common denominators? Can I combine them now? So I'd have 1 minus cosine squared A over sine A. Okay, and there should be an alarm trigger in your head right now because you see a squared. What should we be thinking about? Identities, Pythagorean identities. What is the actual identity? It's sine squared plus cosine squared equals 1. So how do I get this Pythagorean identity to convert into this?
Subtract the cosine.
I subtract my cosine squared over. And when I subtract it over, what's 1 minus cosine squared the same as? Sine squared. So this will now turn into sine squared A on top over sine of A. And then what can cancel on that?
The squared.
Squared, so I can cancel out 1 on top, and I cancel out 1 on bottom, and what would I be left with? Sine A. Questions on that one? Okay, let's look at 8b then. Cross off 8b because that one has that 90 thing in it. We'll do 8c. So 8c, I got secant of x plus tangent of x. And then 1 minus sine x. So are there any identities that I can convert right away? Here? Nothing squared, so no identities, so what should I probably, there's 2 steps I could do, what's one of them? Convert everything to sines and cosine, what's another step? Foil or distribute? It doesn't matter which one I do first, okay? So I'll convert first, so secant is 1 over cosine, tangent would be sine over cosine. And then this is just 1 minus sine. Okay? And once I convert, now I FOIL or distribute. So 1 over cosine times 1 would be 1 over cosine x. 1 over cosine times a negative sine would just be a minus 1 over cosine x times sine x over 1. And then I can distribute this guy. So I can plus sine x over cosine x, because that's times 1. what does the last one give me here? So that'd be a minus. It'd be sine x over cosine x times sine x over 1. What does this turn into here? Negative sine x over cosine x? What do you notice about these guys now?
They cancel.
They cancel. One's positive and one's negative.
I think you cancel if they were addition.
What now?
I think you cancel if they were addition.
This one's a negative though, so since this is a negative and that one's a positive, it's like they subtract from each other.
Wait, but 1 over cosine and sine over 1 don't have common denominators.
You're right, I haven't done those yet though. So the 1 over cosine, correct? Minus, what does this turn into here when you multiply these guys? Sine squared? And then cosine times 1 is cosine x. And now those have common denominators. So what would you do here since they're common now? Combine the numerators. And do we see a Pythagorean identity potentially? Okay. What does 1 minus sine squared turn into? Cosine squared? And then just like that last one, things cancel. So I can cancel out 1 on top, 1 on bottom, and what's my final answer? Cosine of x. Question on that? Alright, we'll do 8D. 8D, we have cotangent of A plus tangent of A over CSE squared of A. What are our thoughts? Probably two things you can do from this. Convert them, let's do that, yep. So what's cotangent the same as?
Cosine of 10.
So we got cosine of A over sine A, and tangent is sine over cosine. All over, what's cosecant? 1 over sine squared. So in order to do this, what do we gotta do on top? Common denominator. Okay, what's the common denominator between sine and cosine? Sine and cosine together. So I'll go cosine A over here, so it's cosine sine here. And that's gotta be cosine sine here. But we have to make it a fraction that's the same thing. So then you see how I'm going to write the same thing on top and bottom here. So the shortcut here would just be cosine A sine A is the bottom of that denominator. And what would the top end up being? Cosine squared?
Sine squared.
Perfect, so cosine squared of A plus sine squared of A.
So 1
Yep, perfect, that's that, and that, what's that called? That's a Pythagorean
identity.
identity. So you guys see right here, this thing, Pythagorean identity will turn into a 1. What's that still over top of that I didn't bring over from the other part?
Sine squared.
Yep, 1 over sine squared of A. Okay, and what's my rule now if I have a fraction divided by a fraction? Flip it, you multiply by the reciprocal, right? I'll just write it out so it's a little neater. So right now I have 1 over cosine A sine A times the reciprocal, which would be sine squared A over 1. Can anything cross cancel right now? Sine A here, cross off 1 sine A there, and I'm left with sine A over cosine of A. What's sine over cosine turn into? Tangent, yep, so then I have the tangent of A, and that's my answer. Questions on that? Alright. Do you want to do graphic or solving? Solving? Okay. So let's solve this. So 2 cosine x equals sine of x. This is number 9a. Okay, so 9a is here. I can't solve and combine things right now because they're two different things. One's sine and one is cosine. Tangent, yes. What is tangent the same as? Sine over cosine. So it's going to be this sine over cosine. And what you do to one side in algebra, you do to the other. So 2 equals, what does sine over cosine turn into then? Tangent x. And is tangent equaling 2 anywhere on the unit circle? Nope. So then what do I need to do from this step?
Inverse.
The inverse, the tan inverse, yep. So go to your calculator, turn it on, and we would go second tan inverse of 2. What mode do I need to be in looking at this problem, number 9? So if you look in the directions, number 9's direction says this.
Radians.
And we know it's radians because it is 2 pi. Yep. So then go to your calculator, put it in the right mode. And I'm in radian, nice.
1.11.
1.11 is the answer, yep. So then if you did the tan inverse, so tan inverse, we get 1.11 is the answer for what x equals. Yep. Questions on that? Alright, let's look at like 10a. Okay, so if I do 10a, I'm solving again. This one says 0 degrees is less than theta, which is less than 360, which means I'm in what mode? Degree mode? So what's the problem on this one? We have a sine and a cosine. The cosine is squared though, which I can probably think what when I see a squared? Pythagorean identity. So on my Pythagorean identity sheet, the identity is sine squared plus cosine squared equals 1. Can I get cosine squared by itself here?
Subtract or divide.
Subtract, yep, the sine squared. And when I do that, what's cosine squared the same as? This, right? So could I replace that right now with a sine squared? So I just took this guy and replaced him in here. And then once I've done that, do I now have everything in sines? Okay, can I then solve this? I have a 2 minus a what? A 2 sine squared. Everything else comes down. Combine like terms. I'd add that 2 to the what? Negative 3. What's a 2 and a negative 3 give me here? Negative 1. And then I would want to factor, but before I factor, I don't like having this negative in front, so I'm going to switch all of the signs. So I'm going to change that to negative, positive. What times what gives me the first term of 2 sine squared? 2 sine times 1 sine gives me 2 sine squared. What times what gives me the last term of 1? 1 and 1. And I gotta get a -3 in the middle, so both of these have to be